Hello everyone, welcome to the Makri Virtual. Hope you are doing good. Today I'm going to continue with your chapter number 6, that is memory hierarchy. Until now we have covered the first topic, that is what is memory hierarchy, what are the contents of memory hierarchy, and what are the operations that we perform on the memory hierarchy, that is disk, CD-ROM, floppy disk, and many other memory devices. Today I'm going to start with your new topic, that is locality. This is your new topic, but before that let's take a quick review what we have covered in the last class. In the last class we have studied about the memory hierarchy continued. We have started with the technology that is SSD, that is your solid state disk. That is a technology or the storage device that emulates a hard disk drive, that emulates a hard disk, or that is a new version of the accomplished with the hard disk drive. We have studied about different technologies or different methods or the internal structure of the IDE connector, internal structure of the SSD, that is a spindle, head, actuator motor, actuator axis, platter, and so on. Then we also studied about the SSD applications, that is where SSD will be used in the computer system, that is your SSD applications. Then we also study what is SSD, or what are the features of SSD. That is in detail we have studied about the SSD. It's a non-volatile storage device. Means when the light has gone on, when the power has gone, the data will not be removed. That is your non-volatile memory. That SSD actually are not hard drives at all in the traditional sense, but they are, because there are no moving part involved. Instead, SSD has an array of semiconductor memory organized as a hard disk using the ICs, that is your integrated circuit. This arrangement means when we use the SSD, this has many advantages. We have studied about the advantages. Then we also studied why it is growing in a rapid way, that SSD has been used by the computer system instead of the hard disk drive, due to their input-output performance. That is, it increases the input and output performance. It easily fetches the data from the user. That is, it takes the input very easily, processes it, and then displays the output very effectively and gives the best performance as compared to the HDD, that is your hard disk drive. But the main limitation is that SSD is more expensive than the traditional or the conventional hard disk drives. Due to the improvement in the manufacturing technology and expanded chip capacity, prices have been dropped so that consumer and enterprise level customers are re-evaluating SSDs as viable alternative to the conventional storage. Then we have also discussed about the SSSI, that is solid state storage initiatives. Then why we use a solid state drives, that why we use a SSDs. There are so many advantages that is available over the magnetic hard disk, over the HDD, that is a hard disk drive. That's why we use the SSD, that is a solid state drive. The majority of this comes from the fact that that the drive does not have any moving part, while a traditional drive have drive motors to spin up the magnetic platters and the drive heads. So there are three types of advantages which the SSD provides. The first one is your less power usage. That is, the power usage that it used, or the SSD requires less power as compared to the conventional hard disk drive, or as compared to the conventional disk drive. So there is less power usage, or there is a less electricity that is used. So this is one of the major or the main advantage that is available while using the SSDs. This is because there is no power draw for the motors. The drive uses far less energy than the regular hard drive. Why SSD uses less power? Because there is no power draw for the motors. Then second one, or second advantage, is that faster data access. That it is very easy to access the data, or it is in fastest ways to access the data from the SSDs or with the help of SSDs as compared to the HDD, that is a hard disk drive. The main motto of every customer or every user that is using the computer, that there is a high speed, that is fast, easy to access, that is faster data access, and that is provided by the SSD, that is your solid state disk. Then next advantage is your high reliability. The output that is given by the SSD are more reliable as compared to the conventional hard disk or the conventional hard disk drive, that is a magnetic disk, HDD, hard disk drive. So this says reliability is also a key factor for the portable drives. Hard disk platters are very fragile and sensitive materials, that is hard disk platter contains sensitive materials. So SSD provides all the data in the memory chips. There are few or the less moving part to be damaged in any sort of impact. So there is high reliability. Customer can rely on the data very easily, and they can rely on the data that is available in the hard drives. Then we also studied about the customer interference, that is why we are using the customer interference. For our customer, however, the write cycle limit 10 to still allows the drives to last roughly 5 years or more, which is longer than the average computer system. Then we also studied about the storage technology trends, that is what are the storage technology trends that is available. There are three types of trends available, that is your progress, then scale out technology, then scale out terminologies. One is scale up and one is scale out. So first is your progress, that how it is used or how well it is increasing the performance of the computer, or how well it increases the effectiveness of the computer. That is your progress. Windows is number one, that is Windows is available at the number 1. Then stepping back, huge progress in the last 5 years. So there is a huge progress in the SSD terminologies in the last 5 years. It is approximately 10 to 100 times improvement. New Windows have compatible or competitive high-end hardware, that is 32 SMPs, 32-bit addressing or 64-bit addressing, more bandwidth, that is in GBs, 30 GBs bandwidth. In the next 5 years, there is also expect that there is a huge improvement, that is from 10 to the 100%. Then recurring time. What is a recurring time? Why? Measure, analyze, and improve. So there are three goals we have studied in the last class, that is your measure, that is your analyze, and that is your improve. Then we also studied about the scalable system. There are two types of scalable test system. One is scale up and one is scale out. Scale up is used by adding the component to a single system, while scale out is used to grow up by adding the more system. Means scale up means using the same system but adding the component to the same system. But scale out means adding the more system to the single system, that is making the network for the system. What really new Windows scale up? We have studied about the Windows features. Then we have studied about the 64-bit. Why bother? Why we bother the 64-bit address for the SSDs? Why? Who needs 64-bit addressing? You need 64-bit addressing. That's why it is studied that from the last 5 years, from the last progress, SSD has increased, and it increased the bits level to the 64-bit addressing. This is the comparison we have studied in the last class. This is the Amdahl's balance system law. These figure shows, or this figure I will tell you, or I have told you in the last class, that how it will use and how it will increase the performance of the program. This is the 5-minute rule. Trade RAM for disk arms. Then we have studied about the 64-bit reduces input output. That is when we are using the 64-bit address, that reduces the input and the output and saves the disk. Save the disk means save the disk or save the memory so that we can access the data, or we can increase or decrease the data, or we can store the data very effectively and efficiently. There are various features that is available. First point says large memory reduces input output. Second point says 64-bit simplifies the code. That is, the code use is very simplified in the 64-bit address. And there is a better response time. This is the example. Then we have also discussed that AMD Hammer is coming soon or available in the computer system to increase the performance of the program. 1 TB main memory is also available in the coming days. Then we also studied about the hyper-threading, that is SMP on the chip. That is why we are using the SMPs and why we are using, or why CPU is waiting for the SMPs. The memory hierarchy, this is your memory hierarchy we have studied. This is the diagram we have studied. This is the memory hierarchy. The registers I cache, D cache, bus, L2 cache, L1 cache, remote cache. This is a scale-up system, that is where how we can increase or decrease the system level performance. Then we have studied about the change ratio matters. That is, if there is a change in the ratio, that matters for the computer system. What really new? This is really new. Height, speed, length. We are here. Then we have studied about the disks are becoming tapes. That is, disks are converted into the tapes in the coming days. Why they are converted into the tapes? Because disks have a low capacity as compared to the tapes. So whenever disks are converted into tapes, so they become high efficient and they become available for the network capacity. Then we have discussed about the networking, that it supports great hardware and the software. Wiring is going serial and getting fast. Then we have studied about the NAS SAN horse race. What really new Windows scale up? This is the new Windows scale up. Take away call to action, that is, we take away the procedure and call to the action that is provided, like threads, locality, 64-bit address, sequential input output, and disk space, low overhead networking, Windows.NET Server 2000 and successors. This is the difference between scale up and scale out. We have studied in the last class. Then we have studied about the availability plus the scalability. That is combination of the availability plus combination of the scalability. Then we have discussed about the two clone geometries that is available for the shared disk, that is shared nothing clones and the shared disk clones. Then there is a clone requirement we have studied. Then partitions for scalability. That is for increasing the performance, we have partitioned the memory into different categories. That is your partition. This is your packs for availability, that we pack or we make the packing for supporting a partition part. That is your pack for availability. Then partitions and disk, this is your partition scalability. Then packed partition, that is your scalability plus availability. Then we have studied about the farm pair. This is a farm pair. Then we also studied about the failover and the load balancing. What is failover and what is your load balancing? This is your cluster level scaling. This is a, combined with each other. These are the examples. This is the example of Terra Software, Hotmail, Google. This is a summary what we have studied. Terminology for scalability, farms of servers, then Geoplex for disaster, architecture blueprint, then call to action. What is a call that is required to action? So that's all for yesterday's session or the last class session. Now I'm going to start with your new topic, that is your locality. This is the topic, second topic, that is locality. This says well-written computer programs tends to exhibit good locality. That is, they tend to reference data items that are near other recently referenced data item or that were recently referenced themselves. This tendency is known as the principle of locality. That is, which reference or what is the location where the data item will be stored that is referenced or that is refers or that refers to the other data item, that is known as the locality or the locality of or principles of locality. This says it is an enduring concept that has enormous impact on the design and performance of hardware and software system. That is, it has a great impact or the enormous impact on the design and the performance of the hardware and the software system. That it affects both the hardware as well as the software systems. Which concept? That is your locality. That is where the data item will be stored in the computer system. This says locality is typically described as two distinct forms. That is, locality is divided into two forms. One is your temporal locality and one is your spatial locality. And this locality concept is used in the cache memory. So let's take a quick review, or let's take with the help of PPT, that is what is covered in the locality concept, how it will relate to the cache memory. So started with the memory hierarchy concept or the memory hierarchy continued. This says characteristics of memory location with respect to processor. That is, first of all, we will study that what is the location with respect to the processor, why we are using the processor, and what is the location that is stored in the processor concepts. So there are 5 parts in this. That is inside the CPU. That is, memory location with respect to the processor is inside the CPU. That is, we can store the data inside the CPU, that is your temporal memory or the register, that is stored on a temporary basis in the registers. Then next point is inside processor, that is also L1 cache. That is, next memory that is used with respect to the processor is your L1 cache. Then next that is used with respect to the processor is your motherboard, that contains 2 parts, main memory and the L2 cache. Then main memory contains 2 parts, that is dynamic RAM and L3 cache. Then there is also external memory with respect to the processor that is used for storing the data, that is such as disk, tape, network, memory devices. So this slide says the memory location with respect to the processor. Then this is the memory capacity word size. That what is the memory capacity that is stored with in the computer memory that is used for storing the word or the content of the computer. The first point says the natural data size for a processor. A 32-bit processor has a 32-bit word. Suppose a processor is of 32-bit capacity, so it can store a maximum of 32-bit word. But if a processor is of 64-bit, then it can store, or the processor can store 64 bits in the 64-bit of the contents. Typically based on processor data bus width, that is a width of an integer or an instruction. That is, it depends on the processor to the processor what capacity they are stored. Suppose if a processor is of 32-bit, it can store up to the 32-bit word. If the processor is of 64-bit, it can store up to the 64-bit. So it depends on the size of the processor. Next point says varying width can be obtained by putting memory chips in parallel with the same address line. That is, varying chip means the capacity or the width of the processor can be used or can be obtained by putting the memory chip in parallel with the same address lines. Then capacity addressable unit, that is your characteristics of the memory capacity with respect to the addressable unit. First point says it varies based on the system ability to allow addressing at the byte level. Which varies? The processor capacity varies based on the system ability that is used for the addressing at the byte level. Then next point says typically smallest location which can be uniquely addressed. That is, the memory that is used has a typically smallest location which can be used or which can be uniquely identified or uniquely addressed. At motherboard level, this is the word. That is the word that is stored in the computer memory. That is your word. It is a cluster on the disk. That next point says addressable unit, that is n equals to raised to the power of number of bits in the address bus. That is when we are using or when we are calculating the capacity, that is calculated by using the 2 power number of bits. Suppose 32-bit processor is used, then it can store maximum of 2 power 32-bit address. That is, the capacity is determined by using the 2 power and the number of bits it can store. Suppose a processor stores 16 bits, so the maximum capacity is 2 power 16. That is your addressable unit. Then characteristics of memory with respect to the unit of transfer. That is the features of the memory with respect to the transfer rate or with respect to the unit it will transfer. The first point says the number of bits read out of or written into memory at a time. Then this is a unit of transfer, that is a unit of the number of bits that is read out or read from the memory at a time. First is your internal, usually governed by the data bus width. That is, the internal memory is usually governed or usually attached by the or attached to the database or data bus width. That is, it is internal memory. It is used with respect to the motherboard. That is your word. Then external memory, usually a block which is much larger than the width of the or the larger than the word. That is, if the content is so high, that is we are using or the computer is using the external memory for this concept. So internal means that is we are using the same concept or we are using the data bus or the internal memory for storing the data, and external means if there is a large number of word or there is a huge capacity to store or huge word to store, that is characteristics or that is governed by the external part. Then characteristics of memory access methods, that is how memory can be accessed. Based on the hardware implementation, there are 4 types of memory access. That is, there are 4 types by which we can access the memory. The first type is your sequential, next is your direct, next is your random, and next is your associative. So there are 4 types by which we can access the memory contents, that is sequential, direct, random, associative. Now let's see one by one what are the 4 methods to access the memory. First one is your sequential access method. That is, it starts at the beginning. That is, it starts searching or start accessing the memory from the beginning and read through in order. That is, it read through the order or it read from the step by step starting with the beginning. Then next point says access time depends on the location of the data and the previous location. So access time is calculated by calculating the location of the data, that is where it is stored, and the previous location from where the output is derived for the current input. For example, tape. That is, if we are using the magnetic tape, this is a sequential or that is a sequential access medium in which the data will be stored one after the another. And if a person wants to access the 5th record, then he or she wants to have to or should have to access 1st to 4th record for accessing the 5th record. Why? Because there is no random access, there is only sequential access. Means the user does not have a facility to fetch directly the 5th location or fetch directly the content of the 5th location. No, he or she have to use the whole location, that is from starting. That is, he or she should have to go through the 1st to the 4th location so that he or she will reach to the 5th location or access the data that is stored in the 5th location. That is a concept of the sequential access memory, and the example is your magnetic tape or the tape. Next is your direct access method. uh, as comparison to the sequential access method, in this there is a direct access to the storage or direct access to the memory, so the data is fetched directly to the memory. First point says individual blocks have unique address, that is every block or the every division or the every part of the memory have a unique address. Access, that is we can access by jumping to the vicinity, then performing a sequential access. Then access time is based on the location of data within the block and the previous location. That is, the access time is dependent on the location of data within the block. Within the block means from where we can fetch the data, it depends on that part as well as the previous location. The example is your hard disk. That is, we can access the data directly from the hard disk by jumping to the vicinity to perform a sequential search. Then next is your random access method. So sequential means the data is accessed sequentially, that is from first to the fourth and then fifth, and then random access means direct access means we can directly access the data by jumping to the location. Next is your random access method, that is randomly access any part depends on the user, that is individual addresses. First point says individual addresses identify location exactly, that is individual address or the memory have a different parts that have individual address that is used to identify the locations exactly, that is what is the location that is exactly used. Next point says, or second point says, access time is consistent across all the locations, that is access time is similar or same for all the locations, because there is no hard and fast rule that we are accessing the same method, but it is a random access, we can access any part. So the access time is consistent across the all the location as and is dependent or independent of the previous access. That is, the access time is not depend on the previous location or the previous access. Suppose I'm using a disk that has 4 parts. If I fetch first part or the first area, then it takes 30 nanoseconds. So it is not mandatory that if I am accessing second part, so it is also accessing next or 4 or 30 nanosecond. No, because every individual part or every part has an individual element, that it does not depends on the previous element or it does not depend on the any other part. So access time is used at depend on the or it is independent of the previous access. The best example for random access is your RAM, that is your random access memory. Then next method for fetching the data is your associative access method. So there are 4 types of method: sequential, random, direct, and then is your associative access method. This says, first point says addressing the information, that is it addresses the information that must be stored with data in a general data location. So with the use of associative access method, we can address the information that is stored in the general data location, or that is stored in a simple location method from where data can be fetched very easily. Next point says a specific data element or a specific data part is located by a comparing desired address with the address portion of the stored element. That is, in associative access method, we can compare the data element or we can access the data element by comparing the desired address. Suppose I want an address that is your desired address, and the address that contains the data is your actual address. So compare both these parts and get the address and get the specific data element. Next point says access time is dependent of the location or the previous access. The access time is fully dependent on the location, that is your location address, and the previous access, that is your previously how it will be accessed and what are the content available or what are the tools available or required for accessing the contents. For example, cache memory. As I told you, cache memory uses the concept that the data is available in the cache. If not, then the CPU fetches the data from the main memory. Now, performance, access time. Till now we have discussed 4 types of accesses, that in 4 ways, in how many 4 ways, how data will be accessed from the memory. Then performance, that is your access time, or what is the performance of accessing the data, that is the time required to access the data, that is your performance. This is the time between requesting the data and getting it, that is your access time. Suppose I am requesting the data, or the computer is requesting the data, that it needs the data, and then computer gets the data. So there is a time gap between the requesting and the getting. That time gap is known as the access time. Now, first point is your RAM, the time between putting address on the bus and the getting data. It's predictable, that is, we can predict the time, or we can predict the access time in advance also. Then next point says other types, that is, what are the other types? That is sequential, direct and associative. The time it takes to position the read-write mechanism, read-write head at the desired location, that is not predictable. Then performance, memory cycle time, that is what is the memory cycle time, or what is the cycle time that requires for the memory access? Primarily a RAM phenomenon. That is, a RAM phenomenon means using the direct access method or using the random access method for accessing the data. Then next point says add the recovery time to cycle, allowing for the transient to dissipate so that next access is reliable. Cycle time is equals to the access plus the recovery, that is access time along with the recovery time. If there is a data loss, that is your recovery. Now next is your performance, or how performance will be affected, that is your transfer rate. First is your transfer rate, that is the rate at which data can be moved, that is your transfer rate. In RAM it is predictable, that is equals to the 1 divided by cycle time, that is already predictable, the rate at which data can be moved. Non-RAM, that is your ROM, that is not predictable, that is generally equals to the Tn equals to Ta plus n divided by R. Tn is the average time that is used to read or write the n bits, and Ta is your average access time, n is your number of bits, and the R is your transfer rate in bits. So this is the formula that is used when there is a non-RAM, that is a ROM is used, that is not predictable. Next is your physical types, or what are the types that is available, or what are the types of memory that is available. One is your physical types, that is your semiconductor, that includes the RAM, that is random access memory. Then magnetic, that includes, or that is of type disk and the tape, that is magnetic disk or magnetic tape. Then optical, that contains 2 parts, CD, that is your compact disc, and the DVD, that is your digital versatile disc. And the others are other types of memory that is used, that is your bubble, old memory. Then hologram, this is the new memory that is used on your credit card. Laser beam are used to store the computer generated data. Suppose I have an ATM card that contains a chip, or that contains a part at the back side that stores my information like my name, address, CVV number, that is your card verification number. So that number is computer generated and stored in a magnetic strip. So that is again your physical type, or that is again a type of concept or type of storage in which data is stored. That is a hologram. Now What are the physical characteristics? It takes less power, degradation over time, that is over time it is degraded, that is your physical characteristics. Then volatility, that is it is volatile in nature, that is RAM versus flash. Erasable, in terms of erasable it is RAM versus ROM. Power consumption, more specific to the laptop, PDAs and the embedded system, that is more power consumed, or the power consumption that is more specific to the laptop, PDAs and the embedded system. Now, organization, how the computer or how a computer memory will be organized in the computer system. That is, organization means physical arrangement of bits into the words. That is how different bits are converted or transferred or arranged in the word or in the text, that is your organization. Not always obvious, that is it is not always obvious that we are using or we are organizing the data. Non-sequential arrangement may be due to the speed or the reliability benefits, that is interleaved. Sometimes it is non-sequential, there is no sequence, that is a non-sequential arrangement. Now, next is your memory hierarchy, that is how memory will be organized in a hierarchy level. So first point says trade-off among three different or three key characteristics, that is amount, speed, cost. That is the memory will be located or memory will be shifted to the different hierarchy based on the amount, based on the speed and based on the cost. It balances these three characteristics with the memory hierarchy, that is your amount, that is your speed and that is your cost. Analogy. Refrigerator and the cupboard has a fast access, lowest variety, freezer and pantry, slower access, better variety. As well, in the same way, grocery store has the slowest access but has the greatest quality. Now, implementation, how it will be implemented. Going down the hierarchy has a following result. So whenever we going down from the upper level to the lower level in the hierarchy, so it has a following result. That is, it decreases the cost per bit, that it becomes a cheaper or it is a cheaper in the low level. Then increase the capacity, that at the top level it increases the capacity, that is your larger. Then increasing the access time, that is slower when we down the or when we down in the hierarchy of the memory, that is your memory hierarchy key, that is decreasing the frequency of access of the memory by the processor. This is your diagram of the memory hierarchy. First is your registers, then a cache memory, that is of two types, L1 cache and the L2 cache. Then main memory, then hard disk or the secondary memory. In the same way, next part is also secondary memory, that is your CD, DVD, then tape backup. This is your also your secondary memory. So in general there are four parts: registers, cache memory, main memory and the secondary memory. And the secondary memory contains multiple parts like hard disk, hard drive, CD-ROM, backup storage and so on. This says more costly, more costly. The access time is increasing, that is 1 nanosecond, 2 nanosecond, 3 to 10, 25 to 50, 30 to 90 nanoseconds. So this is increasing while going to the up to the down, from top to the bottom. Then mechanisms or mechanics of technology. The basic mechanics of creating memory directly affects the three characteristics of the hierarchy. That is, when we use the hierarchy, there are three mechanisms of creating the memory directly. There are three characteristics. One is your decreasing cost per bit, then increasing the capacity, and then increasing the access time. That is, whenever we go from the up to the down, it decreases the cost, but increase the capacity and increase the access time. The fourth characteristics is met because of a principle known as the locality of reference. So this is your most important concept, that is locality of reference. Now, in class exercise, this is the exercise. This is the code that is used in the C language. Now, what is the locality of reference? This says, due to the nature of programming, instructions and data tend to cluster together. Why? Because of the nature of the programming, these are cluttered together. That is, it is or they are stored at the same location. That is the nature of the programming. That is loops, subordinates, and the data structure combined with the each other. Over a long period of time, cluster will change. That is, in a long period of time, this cluster will be changed. But over a short period, cluster will tend to be the same. So, cache and the locality. Cache memory lies between the CPU and the main memory. This says cache lies between the CPU and the main memory, invisible to the CPU. Only useful, which cache memory is only useful if recently used items are used again. Fortunately, this happens a lot. We call this property locality of reference. So in simple terms, if data is available if cache memory is used for giving the data to the cache CPU and then perform the operation, that is known as the locality of reference. That is, the data is located from the cache memory and CPU uses that data for performing the operations. So that is your locality of reference. Now, there are two types of locality of reference. One is your temporal, then is your spatial or spatial. Then in temporal, it is said recently accessed data instructions are likely to be accessed again. That is, in temporal locality, the recent data or the recent used data are likely or is likely to be accessed again and again. That is a temporal locality. The first point says most program time is spent in the loops. Then arrays are often scanned multiple times. So there are two parts, that is multiple program or the most program time is spent in the looping. That is your for loop, while loop, do while loop, and arrays are often scanned multiple times. So that is a temporal locality. In spatial locality, if I access memory address n, then I am likely to then access another address close to the n, that is n plus 1, n plus 2 or the n plus 4. That is our spatial locality. So in temporal locality, it is used for the loops, for the arrays. But in spatial locality, it is used for the addressing the next part. That is, if I'm using one part, then in spatial locality, it will address to the next part, to the next part, to the next part, till continue till the end of the parts. That is linear execution of the code and the linear access of the arrays. That is a spatial locality. So one is your temporal, another one is your spatial locality. Then how a cache exploits the locality, or how cache will be used, or how cache is using the locality of reference. So there are two parts, one is your temporal, another one is your spatial. So when an item is accessed from the memory, it is brought into the cache memory. That is your cache, temporal cache. That is, once a data is fetched or once a data is available in the cache, it is fetched and it is accessed and stored in the cache or the CPU. If it is accessed again soon, it comes from the cache, not from the main memory. Next is the spatial. When we access a memory word, we also fetch the new words of the memory into the cache. As in this slide, we have studied, this is close to the next one, so it will access next one, next one, next one. So this also says if it is accessed again, that is, or if it accessed soon, that is, if I am accessing the elements and after 2 minutes or 2 nanoseconds, I am accessing again the element that is stored in the temporal location. So it is the CPU fetched from the temporal location, temporal locality instead of the cache memory. Then next is your spatial, that is, if I am accessing the memory word, so it also access the next few words of the memory into the cache. That is 2 or 3 words, that is successors of the next word or successor of the element that is fetched from the memory. This is the number of words fetched in the cache line size or the cache block size for the machine. Then locality. One recent past is a good predictor of his or her near future. One is your temporal locality. If you just did something, it is very likely that you will do the same thing again soon. That is a temporal locality. Since you are here today, there is a good chance you will be here again and again on a regular basis. Then spatial locality. If you did something, it is very likely you will do something similar or related. Every time I find you in this room, you are probably sitting close to the same people. That is a spatial locality. A typical program has a lot of locality in the memory references. Typically, programs are composed of loops. There is a temporal locality, there is a spatial locality. Now, cache basics, that is how to exploit the temporal locality. First of all, let's see with the help of the book. This is, we have discussed about the temporal locality and the spatial locality. Programmers should understand the principle of locality because in general, programs with good locality runs faster than the programs with poor locality. Now, locality of reference to the programmed data, that is your temporal locality. This is the example that is discussed. A function with good locality, this has a good locality, this has a reference matter for the vector 8. This is the good locality, that is using the for loop, using the sum at the different places. This is a good locality function. Again, next example. Now, next is the locality of instruction fetches. This I will discuss, but first of all, let's take 5 to 10 minutes break and then come back starting with the same topic, that is caching basic, how to exploit the temporal locality. So first of all, let's take 5 to 10 minutes break. So let's take 5 to 10 minutes break. Now, starting with the next slide, that is your cache or caching basic, how to exploit the temporal locality. Now, started with this slide. That is how to exploit the temporal locality. The idea is that store the recently accessed data is automatically managed fast memory, that is cache. That is how to exploit the temporal locality by storing the access data or by storing the result in the automatically fast memory, that is your cache memory. Then anticipation, the data will be accessed again soon. Temporal locality principle, recently accessed data will be again accessed in the near future. That is, it is the principle of the locality or temporal locality that the data that is used will be accessed or will be accessed in the future very soon in the near future. That is, will be again accessed in the near future. That is, or this is what Morris Bikes had in mind. That is, slave the memories and dynamic storage allocation, that is IEEE transition or transmission on electronic computer, that is 1965. Then how to exploit the spatial locality? The idea is that store the addresses adjacent to the recently addressed one in automatically managed fast memory. That is, store the addresses that is equal or the adjacent to the most recently one in automatically managed fast memory. Suppose I'm using n, then I'm also accessing, or the computer memory or the physical memory is also accessing n plus 1, n plus 2, n plus 3, n plus 4 and so on till the last value. Then it says logically divide the memory into the equal size block. That is, it divides the memory into the multiple parts, that is your equal size blocks. Then fetches to the cache the address block into the entirely. That is, fetches the cache memory into the address block in its entire position. Then what are the applications? Application is nearby data will be accessed soon. The principle of spatial locality says nearby data in memory will be accessed in the near future. That is, example, sequential instruction access, that is array traversal. That is what IBM 36085 implemented. That is what IBM organization will be used, the spatial locality. The next slide says breaking the memory into the different levels. Now, this is the most important slide. This says assumes a hypothetical system has two levels of memory. Level 2 should contain all the instructions and the data, and the level 1 does not have a room for everything. That is, level 2 contains the instruction and the data, but level 1 does not have a room. So when a new cluster is required, the cluster it replaces must be sent back to the level 2. That is, level 2 have no room. So everything is stored in the level 2 because level 1 does not have a room for everything. These principles can be applied to much more than just two levels. If the performance is based on the amount of memory rather than the speed, low levels can be used to simulate large sizes or the larger sizes for higher level, that is your virtual memory. Example is your virtual memory. This says we can divide the memory, we can break the memory into the different level, and we are using multiple level for storing the data, for storing the instructions and the data, because single memory is not efficient or not perfect for storing the data. So computer uses more than one level or more than one place to store the data. Then next is your memory hierarchy examples. This is the example. If 95% of the memory access is found or are found in the faster level, that is 95% memory is available in the faster level, then the average access time or the minimum time access time that is required is your 0.95, that is your 95% into 0.01 US plus 0.05, that is a remaining 5% multiplied by 0.1 is equal to this one, that is sum up, and that is equals to 0.015 US. This is the performance of a simple two-level memory. This is the diagram that shows this is the average access time and this is the fraction or the hit ratio. Next, hierarchy list, that is a list of the hierarchy that is used. So first is your registers, that is volatile in nature. Then L1 cache, that is again volatile in nature. Then L2 cache, again volatile in nature. Then next is your main memory cache, that is again volatile in nature. Then main memory. So before that there is a cache memory, that is CD-RAM cache, that is a volatile in nature. Then next is your main memory, that is again volatile in nature. Then disk cache, then that is again volatile in nature. Then next is your optical or the disk, that is non-volatile in nature, that is a part of the ROM. Next, optical, that is again non-volatile, that is a part of the ROM, that is a backup, that is used for backup, that is a secondary storage. Next, tape, that is also a secondary storage, that is your non-volatile memory. So these are the hierarchy lists that is available in the computer system while storing the data and the instructions, and that is used by the CPU. So one is your registers, then L1 cache, L2 cache, cache memory, main memory, disk cache, disk, optical, tape. So some are the volatile memory and some are the non-volatile memories. Now, what is cache or what is it? A cache is a small amount of fast memory. Why it is used in small amount? Because it is required in the small quantity, or it is required, or it can store less amount of or small amount of the data and instruction, but the advantage is that it is very fast memory. What makes small fast? That is, what is the reason why it is small and why it is fast? The first reason is that simpler decoding logic. That is, the logic that is used in cache memory is simple for decoding the instructions. That is one of the phase of the instruction, that is decoding. So it is a simple decoding logic that is available in the cache memory. More expensive than the static RAM or the SRAM technology. So this why it is small fast, because cache memory is more expensive than the SRAM technology. Then it is very close proximity to the processor. That is, cache memory is very close to the processor. Cache sits between the normal main memory and the CPU. or it may be located on the CPU chip or the module. That is, it is very close to the processor. That is why the time is very fast, or the time is very fast as compared to the main memory, because the fetch or the data fetching is very fast. Why? Because it lies, or the cache memory lies very near to the CPU. This is a diagram of the cache memory. There is a CPU, there is a main memory, and cache memory lies between the CPU and the main memory. There are two bidirectional, or there are bidirectional angles. One is this one, and one is this one. One is right side, one is left side. So this is data is also fetched from the CPU, and data is also going to the cache memory. So this is arrow represent the going from the CPU to the cache. This arrow represent coming data from the cache to the CPU. In the same way, going data from cache to the main memory, and coming data from main memory to the cache. And in this, that is between the CPU and the cache memory, there is a word transfer. That is transferring the word from the CPU to the cache. And in this, there is a block transfer. That is more than one word, that is your combination of words can be transferred from the cache memory to the main memory. Then cache operations. What are the cache operations that is available on the main memory? This says CPU request contents of the main memory. That is central processing unit requests the content of the memory location. That is your operation. Then check cache for this data. Then cache memory checks for the data, that if data is available in the cache memory or not. If present, get from the cache. That is, if data is present in the cache memory, so get the data from the cache memory in a fast speed. But if it is not present, that data is not available in the cache memory, one of the two things happen. That is, there are two probabilities. That is, two scenarios will happen or would happen. First, it reads the required block from the main memory to the cache, then deliver from the cache to the CPU. The first point says, if data is not available in the cache memory, then either it can read the required block from the main memory, or read the data from the main memory to the cache, then deliver the data from the cache to the CPU. That is, delivering the content from the cache memory and pass the content to the CPU, so that CPU performs the operation and produce the output. Next point, or next probability is that read the required block from the main memory to the cache and simultaneously deliver to the CPU. That is, in first point, it delivers from the main memory to the cache and then cache to the CPU. That is in two terms. First of all, main memory to cache and then cache to the CPU. But second probability or second method is, at the same time, passing the data from the main memory to the cache, in the simultaneously use, it delivers the data to the CPU. So in first point, in first probability, there are two concepts. In second probability, there are only one concept. In bracket, it is said CPU and cache both receives data from the same data bus buffer. Now let's see with the help of book what is covered in the book. This is your locality, this is your locality of reference, this is the example, CRA example. Next is your locality of instruction fetches. That is how locality of reference will be used in fetching the data from the C programming or any programming language. This said, since program instructions are stored in the memory and must be fetched by the CPU, we can also evaluate the locality of programs with respect to the instruction fetches. That is, with reference or in reference to the locality of programs, we can use the instructions that is fetches from the memory. For example, in figure 19, instructions in the body of the for loop are executed in sequential memory order, and thus the loop enjoy the good spatial locality. What is spatial locality? That is one after the another data will be stored. So this is the best example. First of all, it is 0, then next j plus 1, j plus plus, that is 1, then j2, 3, 4. So it is going, or it is increasing from the 0 to the 1, 2, 3. So it will increase from the 1, 2, 3, 4, 5, 6. That is your spatial locality, or that enjoys the spatial locality. Now let's see the syntax, or let's see the programming code. This is int sum array calls, that is using the function that is sum array columns, and the return type is int. In bracket there is a argument that is int amn, that is taken the array that is your int, that is of int type, and the array or the matrix that is of m and the n. So there are m number of rows and the n number of columns, and the array name is your a. Then using the variable that is ij, and initialize the sum to the 0. Then uses the for loop that is j equals to 0, j is less than n, and j plus plus, that is starting with 0, ending with n, and then increment the j values. Then in the inner loop, take one more loop, that is the inner for loop. Take the I value equals to 0, I is less than m. So first of all, it is less than the column, then it is less than the rows, that is I is less than m, I plus plus, that is incrementing the value. So first of all, outer loop will initiate, and then inner loop will initiate. But until and unless inner loop will not terminate, the cursor or the method will not jump to the outer loop. So first of all, fully inner loop will be executed, then return from the inner loop when the condition is false, then go to the outer loop, again executing the loop, again go to the inner loop, again executing the inner loop. When the condition is false or condition is not true, again go to the outer loop. In the same way, the method follow until the condition is true. So this is j is less than number of columns, and I is less than number of rows. Sum plus equals to aij, that is sum contains the value, or in sum there contains the value that is ij. First of all, I is 0, j is 0, that is at 0, 0 location. Then 0, I is 0, sorry, j is 0, I is 1, that is 1, 0. Then 2, 0, 3, 0. In the same way, it will increment, and then next j equals to 1, I equals to 0, that is 0, 1. Then at last return the sum, that is return the variable that is stored in the sum, that is return sum. This is the function with poor spatial values. This is a reference pattern for the array m equals to 2 and n equals to 3. This function or the function has a poor spatial locality because it scans memory with the stride and reference pattern. So because it is started with the column, not started with the rows, it has a poor spatial locality. Now next is your summary of locality. What is the summary? But before that, let's take a review of the slide. Next slide is your going deeper with principle of locality, that is going indulge in the principle of locality. That is, cache misses are unavoidable. That is, whenever we use a cache, that is cache misses. Misses means content is not available in the cache memory, that is unavoidable. That is, every piece of data and code thing must be loaded at least once. That is, at least once data is available in the cache memory. What does a processor do during a miss? That is, if there is a miss condition, what is the role of the processor, or what a processor do? It waits for the data to be loaded. So if there is no data available in the cache memory, so data or the processor will wait for the data until the data will not be uploaded. Then next, power consumption varies linearly with clock speed and the square of the voltage. That is, the power consumption is dependent or varies along with the clock speed and the square of the voltage level. Then next point says, Adjusting the clock speed and the voltage of processor has the potential to produce cubic power reduction. So whenever the clock speed will be adjusted and the voltage level of the processor will be adjusted, so it will produce the cubic, or it will reduce the power, or it is used as a power reductions. Then next point says identify the places in class in-class service exercise or in-class exercise where this might happen. That is, places the data in the cache memory whenever there is a miscondition, so that processor can fetch the data from the cache efficiently and effectively. Next is your cache structure. That is, what is the structure of the cache? Cache includes tags to identify the address of the block. That is, cache is used or includes or has a tags to identify the address of the blocks of the main memory that is contained in the line of the cache. So cache includes the various tags that is available to address the block of the main memory, or to identify the address of the main memory that is contained in the line of the cache. Each word in main memory has a unique n-bit address. So every word of the main memory has a unique n-bit address. There are m equals to 2 power n divided by k block of k words in the main memory. This is the number of blocks of the k word that is available in the main memory. Then next point says cache contains, or the cache memory contains c lines of k words. That is, it contains, there are total number of C lines of the K words each, plus a tag that is uniquely, or that is used to uniquely identify the block of the K words. That is used to identify the block of the K words. So this is a cache structure. That is, what is the internal structure of the cache, or how cache works. That is your cache structure. This is your cache structure in a pictorial representation. This is your tag. This is your line number from 0, 1 to C-1. Then these are this figure, that is a 4 bits, is used for the tags, and there is a block. This is, there is a tag and there is a block. Includes a tag to identify the address of the block of the main memory. So this is tag that is used to identify the block. This is the block length, that is your K words. This is in this direction, this is in this direction. This is your block length. Then memory divided into the blocks. That is, the cache memory is divided into the multiple blocks. This is your memory address 1, 2, 3. This is the block of K words. This is one block, another block, another block, another block. That is block of the K words. This is also a block. There is a word length. This is a word length, and the length of the word is 2 power n minus 1. That is your another block. So this is the block of K words, another block 1, 2, 3, and this is the block, or this is the memory address. So this slide shows, or this diagram shows, how memory, or the how memory contents will be divided into multiple blocks. Now let's see with the help of book. In this section, that is a summary of locality. In this section, we have introduced the fundamental idea of locality and have identified some simple rules for qualitatively evaluating the locality of the program. That is how we can qualitatively evaluate the locality of the reference. First point says programs that repeatedly reference the same variable enjoy good temporal locality. That is, the program that are used in a repetitive way enjoy the good temporal locality. For programs and stride K reference patterns, that is, for the programs and the with the stride K reference program, the smaller the stride, the better the spatial locality. That is why, that's the main reason why the spatial locality will follow or will use another locality also, or the coming or the successive locality also. Next, loops have a good temporal and the spatial locality with respect to the instruction fetches. As we study, loops have a good amount of the spatial locality and the temporal locality. The smaller the loop body, the greater the number of loop iterations. That is the better the locality. Later in this chapter, we have learned about the cache memory and how they work. This is the example, practice example. Permute the loops in the following function so that it will scan or it scans the 3-dimension array A with the stride 1 reference pattern. This is another example. Next is your memory hierarchy that I will discuss in the next class, that is in the tomorrow's class. So that's all for today's session. Now, if you have any doubt, then please text the doubt and I will answer you. But before that, let's take a quick review what we have covered in the today's class. In today's class, we have started with the memory hierarchy, that is continued of the memory hierarchy. Then we have studied about the features of the memory, that is characteristics of the memory with respect to the processor, that is location is used with respect to processor, that is where it is stored, that is inside the CPU, inside the processor, inside motherboard, main memory, external. Then what is the content or what is the capacity of the memory, that is its stored word size,